Your RAM can actually be hacked by using a hammer. Sounds ridiculous, right? But I bet you're gonna get an orgasmic feeling after watching this video, so bear with me till the end. This particular hacking technique is dependent upon the physics that we actually live upon, unlike some noob software hacking. So in order to understand this, you have to understand some basic things, right? So let's talk about this attack a little bit. This attack is very sophisticated in order to understand. So you have to understand how the internal hardware of RAM or DRAM, DDR3, DDR4 actually works. So let's talk about some of the basics, right? Let's talk about capacitor first. So the first thing that you actually have in a capacitor is what is a capacitor. So a capacitor is a very simple device which is basically holding charge. So if you had a capacitor connected to a cell and you give it a charge, then it will hold the charge for a moment in real life. But ideally, it should hold it forever. But since we are talking about real life, it holds for a certain amount of time because the charge gets leaked out to anything, even air. So like if you join a load to a charged capacitor, it'll immediately discharge. Like it is a battery basically, but it charges immediately and discharges immediately if you give a load. But if not, if you do not give a load for a certain amount of time, it is actually going to hold it. So now the thing is the transistor. So transistor is basically a switch, right? So it is very fantastic device because it is the source of all of the innovations that we actually have in computers. But let me put it this way so that it is really easy to understand, right? Consider a physical switch. A transistor is also basically the same thing, but instead of your hand, you actually give a voltage or you actually give a current in order to turn on the transistor or turn off the transistor. So let's consider a circuit in which a current is actually flowing from here to here. Now we want a switch, so we place a transistor there. So in this particular arm, if you give any current, then it will allow the current to pass from left to right. But if you do not give anything, then it will not let it pass. So because of that, what happens is that it acts like a switch. So the basic uses of this thing can be amplifying. So you have a very dim electrical audio signal that is connected to this particular arm of the transistor. And in that particular arm, what you actually do is put the very small signal, and the big signal can actually be produced from the other side because you can give a big amount of current from this particular arm. Another thing that we have to understand is about DRAM unit now. Now you have the understanding of transistor and capacitor. Now what you have to do is mix these two. Now after mixing the transistor and capacitor, you can basically create this particular structure, which is a unit in RAM, the random access memory that is going to be hacked today. Now we are actually ready to understand how this DRAM works. The capacitor actually stores the information and the transistor is used to read and write the information to the capacitor in binary, meaning something or nothing is actually stored there. So if the controller puts the current into the transistor from here, the arm in which it acts like a switch, then the transistor gets switched on. And from the left side, what it happens is that from the bit line, if you give 1, meaning something, some current, then what it happens is that the capacitor actually gets charged and 1 is actually stored there. But if 1 was already there, then nothing will happen because there is no any potential different and no change is needed because already 1 is stored in the capacitor. This is called basically the write. So in another case is that if you want to write 0 into the capacitor. So in the bit line, what happens is that there is nothing in the bit line, but you make the switch on. So if the capacitor had 1, then it would flow into the bit line, and then it would have 0. So you have successfully written 0 in the capacitor. If the capacitor already had 0, then no need to do anything because it is basically 0. That's what we want. Remember that we are only talking about a single unit because there are a lot of things, right? We're talking about a single unit in RAM. So another thing is that we have to talk about read operation. Now this is the write operation, how to write 1 and 0 into the capacitor. Another one is how to actually read in the capacitor. Now let us see how we are going to read from the capacitor. Consider that 1 volt is digital information on and 0 volt is digital information off. In that case, then we put the bit line into 0.5 volt. Previously, we actually used bit line in order to write or read the information. Now what we're going to do is we're going to make 0.5 volt into the bit line. So now what it happens is that if nothing is there in the storage capacitor, ideally it should be 0 in the capacitor, right? but by leakage, let us say it is 0.3 volt. Then the charge flows into the storage capacitor, and we would know that it is 0 by the sensor and the bit line. Similarly, if you have something in the capacitor, ideally 1 volt, but 0.7 volt by leakage, then from the capacitor the charge flows to the bit line, by which we will know that it was 1 by the sensor. But the thing is, you can see after the read operation, the data in the capacitor is ambiguous. So we have to write back the same data we see in the capacitor. This is called the refresh operation. Now, this has to be done really frequently because the stored bit gets lost too fast because of the leakage. So what you do is read it, write back, read, write back, read, write back. This is known as refreshing in RAM, DRAM. So there is a leakage as well in the read operation, right? So since 0.5 volt is ambiguous in the capacitor, and if by leakage or any other phenomena it actually changes from 0.7 volt, which is on, to 0.4 volt, which is off in the storage capacitor, then we have bit flipped it. Now consider this bit is storing Boolean value for whether you should have root access or not in your computer. You are doomed, basically. Now we're in the position to understand Rowhammer attack. Hackers have found that if we repeatedly do a read operation that causes ambiguity, as discussed earlier, it actually leaks charge to adjacent rows. And if exactly between subsequent refresh cycles, we are able to leak or inject just enough charge to go from 0.49 volt to 0.51 volt, then the bit gets flipped and you're hacked, basically. So I bet you have got an orgasmic feeling that I promised about, because this is a really interesting thing. So the history of this attack actually dates back to 7 BCE, before COVID era, where we had DDR3 RAM. Then RAM wasn't so dense, so leaking enough charge through an aggressor row, meaning the row in which we do read operation aggressively, needed a lot of hits, like 139K to 314K read for that much amount of time in order to leak enough charge in the adjacent row in order to flip the bit. But in DDR4, since RAM got denser, the job was done in 20K to 80K. So in order to mitigate this, DDR5 manufacturers increased their refresh rate and installed a proprietary Rowhammer detection system there, but new research actually shows that it is also hackable. So no one is safe in the world, so stop worrying and enjoying your life. Like, share and subscribe. Thank you for watching.